In question number 1, we're going to be asked to factor each cubic. A cubic is a perfect cube, and every time we have a perfect cube, there's a special pattern to its factors. We can use this pattern instead of doing long division or something that takes a long time. The pattern with cubics depends upon you having two terms, both of which are perfect cubes, which means that some number times itself 3 times gives you each of those things. Now, the first thing we're going to notice about number 1 is that the terms seem to be in a very strange order. So it might make sense if we rewrite it as y cubed minus x cubed. That's fine since we haven't changed any of the signs, and it might make more sense like this. The pattern for perfect cubes says that the factors, which are twofold, have a short one and a long one. The short factor is relatively easy to find. It comes from the cube roots, or the numbers that we would have had to cube to get each of the 2 original terms. So since y times itself 3 times would be y cubed, the first term is y. Since negative x times itself 3 times would have been negative x cubed, that's our second term. So our short parentheses will be y minus x. The longer parentheses depends upon a certain pattern with those 2 terms. The pattern is relatively easy to see, but let me quickly illustrate it. There are 3 terms in the long parentheses. The first term comes from the first term in the original short parentheses squared. So since y times itself is y squared, there's the first term in our short. The last term in our long parentheses comes from the last term in the short one, squared. So since x times itself would be x squared, there's our last term. The middle of that long parentheses comes from the 2 original terms multiplied together with the opposite sign. So x times y would be xy, and the opposite would be positive, so we call it plus xy. Now, if you're in Miss Clarkson's class, you probably heard that phrase opposites attract. So in this middle, where they come together, you'll see that they switch signs because opposites attract. So again, the pattern in the long parentheses is squares on the ends, and together the opposites attract. Let's use the same pattern in question number 2, and let's see if we can recreate this. In question number 2, again, we're dealing with perfect cubes. We'll have a short parentheses and a long parentheses. The short parentheses come from the perfect cubes. 216 came from 6 cubed, and 8y cubed came from 2y. So as we take a look, we'll know that we'll start with 6 minus 2y. Now, generally speaking, this first one takes the same sign as the original. So since this was negative 8, we were cubing negative 2. Now again, let's look at our pattern. We know that there are 3 terms in the long parentheses. The first term comes from the first term in the short one, squared. So 6 squared is 36. The last term in the parentheses comes from the last term in the short one, squared. So negative 2y times negative 2y would be positive 4y squared. The middle, again, opposites attract, come from multiplying those 2 terms and then changing their sign. 6 times negative 2y would be negative 12y. Change the sign, positive 12y. There are our factors. Same thing goes even in question number 3. Question number 3 looks rather intimidating, but it's not. We just have to recognize that they're all perfect cubes. In this first part, m cubed, n cubed, we realize that m and n would both have had to be cubed to get that first spot. So we know that the first term will be mn. This one must come from r and s both being cubed. So we know the cube root there would be rs. Again, setting it up, we know we have short parentheses and long parentheses. The short parentheses are those basic cube root terms. So mn plus rs. Since this guy was positive, this guy is positive. Now, once again, we utilize our pattern. The first term squared gives us the first term in the long parentheses. So mn squared would be mn times another mn, which is really m squared n squared. It might look a little bit awkward, but that's definitely the way it's going to look. I'm going to erase this and give myself a little bit more space. These are long terms after all. When we look at the last term in the original parentheses, squared, we again are doing the same thing, rs times rs, which would be written as positive r squared s squared. Now for the middle, where again, opposites attract. We have all of those terms multiplied together, and we'll need to change their sign. So m times n times r times s, with an opposite sign, would be minus m n r s. It's a lot in there, but it's definitely all going to work. And as we look back at all three of those problems, we'll notice the same pattern all the way through, short and long. And each time we have the long, it comes from squares and that merge in the middle where opposites attract.